So wherever the seats are for yours, you're going to put an X there. So you should end up with 10 X's. Different places on here. Make sure that you have 10. Circle them if it's easier to see, because we're going to want to make sure that we can identify which seats these are when we get to this next section. This is simple random sampling. How do we abbreviate simple random sampling? Does anybody remember? SRS. Because math does nothing if not abbreviate everything it possibly can. If you can't get the random number generator to work, please let me know, because there are other random number generators that we can use. They're just a little bit more cumbersome. So simple random sampling, SRS, you label everybody. We use a random number generator to pick out however many we're sampling. In this case, it's 10. And then we select the people in those corresponding seats. Label, randomize, select. That's what we do for an SRS. What do you notice about your random sampling? A lot of people towards the front. And that was just using a random number generator, so they didn't necessarily, like the random number generator didn't know how these seats were arranged. But Jenna was saying that she had a lot of values up here. So while it was random, is it getting very good representation across these 50 seats? Some people's sample's probably better than others. So I want to look at another way of picking out a simple random sample. So for method number 2, we're still going to use your random number generator. We are going to randomly choose 2 fans from each horizontal row. So I'm going to have my rows 1 through 5. And then our seats would go 1 through 10 across the top, right? So row 1, seat 1, row 1, seat 2, all the way to seat 10. Row 2, seat 1, row 2, seat 2. A lot of times in theaters, they'll give them letters instead of numbers. So far, so good? So now what I want you guys to do, on your random number generator, instead of going, I'm going to hit go back here. I don't want 10 unique random numbers. I want how many? 2. I only want 2 random numbers now. And I want it to go from 1 to what? 1, 2, because I want 2 seats from each row.
10.
From 1 to 10. And I'm going to have to do this 5 times. All right, so they picked out seats 4 and 10 for me. So on this, my first one would be here's seat 4, here's seat 10. And then I'm going to go back and do it again. I can just hit the again button. Oh, they picked out 5 and 9 for me this time. I want you guys to be doing this on your own. You should not use the same numbers as me. But you need to run this simulation 5 times, 2 seats in each row. Yours should not look like mine. Start with the first row, label our seats 1 to 10. Use a random number generator to select 2 random numbers. Select people in the corresponding seats and repeat for all the rows. So you should end up with 2 here, 2 here, 2 here, 2 here. You shouldn't have that. Yeah, tell me your first set of random numbers.
It was 1 and 9.
1 and 9. So 1 and 9.
Oh, I thought it meant like 1. All right.
So the first one you do is in row 1, and you pick out those 2 seats. Now you're going to move to row 2.
Oh, okay.
Do another random number generator.
It's 3, 8.
You got 3 and 8. Okay, so 3 would be right here. No, you're right. That was correct. You said it was for 3 and 8 the next time.
Yeah.
So 3 and 8 out of that row.
And the next one was 5 and 7.
Okay. And now you're going to do that 2 more times. So you need to repeat these trials 5 times. You should, in each and every row here, you should have 2 seats. This is going to fix that problem of having too many people close to the stage. You're going to get 2 people from all 5 rows for a grand total of how many? 10. 2 people from each of these rows. What we're doing here is called stratified sampling. In this case, our strata are our different rows. Does anybody have the problem this time where there's too many people up close to the stage? No, it's pretty evenly spread out as far as close to the stage and farther away from the stage. Is anybody having issues with like either all the seats got picked as like you are dead center, or some people like all the seats that you sampled ended up being off to the sides? Do you think that could possibly affect people's enjoyment of the show? I want to do the same thing that we did here with a little bit of a change. Instead of using the rows as our strata and picking 2 seats from each row, for this last one here, I want to choose the columns as our strata. I want 10 people total. How many columns do we have? We have 10. So how many people from each column would I want to pick if I want 10 people overall? 1 person from each column. So I just want a single random number. So 1 through 10. And we've got seats 1 through 5 now. I want 1 random number between 1 and 5. And I'm going to do that 10 times. So this time we just want 1 single random number. If you're not sure if you're doing it correctly, let me know, but you want to use your random number generator. You want it to pick 1 single random number between 1 and 5, and you have to repeat that 10 times over, so you end up selecting a total of 10 seats. So it should be going this way. 1 out of each of these. So you want it to just pick 1 number. Okay, good. So for set 1, you're just going with seat 3.
Okay.
For set 2, you just have seat 2. So just this one.
This one?
Mm-hmm. Yep, so erase those.
I thought it was like...
Sorry, yeah. So this one would actually be this seat right here. Third one down. That's your set 1. So for this column, seat 3. For this column, seat 2. For set 3, go ahead and erase that. You're going with seat 5, so just that guy at the bottom.
Okay.
There
Wait,
you
so
go.
the sets are the...
Sets are this way on this one.
Oh,
For this one, we were going this way.
Mm-hmm.
For this one, we're going this way.
Okay,
Does
that's
that make
fine.
sense?
Yeah.
Okay. Like this should not have happened here.
Mm-hmm.
you have 4 in a single row. You should only have 2 in a row like this. So one of these guys belongs down here and one of them belongs down here because you should have 2 there. Yes, sir.
I need help.
Okay, this kind of situation should not have happened. So let's look. Set 1, you've got to go in too big. Let's go back. You want one number between 1 and 5. So you want to change that to a 5 there. There you go. Hit go. There you go. All right, let's get your set. All right, so in this first one, you're going to go with the second seat down. This right here, second seat down. Yes, and now we'll do it again. And now it's seat 5. All right, so we're going to have to do the same for these others. Does that make more sense?
Yeah.
Okay. I do it again. Went with seat 3 this time. Nope, that's seat 1. So you're, down in seat 3. Now you've moved over here, hit it again. Seat 5. Seat 1, there you go. Do it for the next one. Seat 4, there you go. Go ahead and finish it up like that.
Thank you.
You're welcome. All right, so way back here with our simple random sample from the beginning, they're just kind of all over the place. In this second one, you should only have 2 seats in each of these different rows of seats. You should not have any more than 2 seats selected in any long row. In the last one that we did, we're looking at columns, so you've got 1 seat selected. 1 seat selected. You would not have 2 in any columns here. Is that what yours look like? Because I want to make sure that we're all on the same page here before we actually do any calculations. So make sure on this last one, for any vertical column, you don't have any more than 1 seat selected. For the second one, in each row, you should have exactly 2 seats selected. So far, so good? If you're not sure if you've done it correctly, let me know. Looking at these 3, looking at how it's spread out across these 50 seats. Initial gut check impression, which method do you think is the best? The purely simple random sample, stratifying using our rows, or stratifying using our columns? Which one appears to be giving us the most general coverage of the audience? Columns? Okay. And honestly, this is something that can change from time to time. Thank you. When I did this on my own earlier, the rows one looked like it had the best coverage. Sometimes columns works out best, like this one. One of the things that I noticed happened on mine when I did it is I ended up with a bunch of people that were actually back here. For whatever reason, my random number generator wasn't giving me anybody close to the stage at all. There's problems that can arise with each of these, but you guys said you thought the columns was the best. Why? Most spread out. All righty. Most spread out / good overall coverage or representation of these 50 seats. So when we're doing stratified sampling, you want to choose strata based on characteristics that may affect the responses. So as you're thinking about things that would affect people's enjoyment level of the show, what do you think people are going to think if they're closer to the stage?
They like it more.
Probably like it more than people that are farther away. Could we make the same kind of argument about people that are off to the edges versus in the center? Yeah. So on this case, I could go with strata that either are rows or columns, and I might have to test it both ways to see which one actually is tending to affect my outcome more. But when we're using stratified sampling, we want to choose our strata based on characteristics that we think may affect our responses. One of the common strata that we see used in different types of sampling or different studies is based on gender. They'll split people. They're like, do guys and girls have different opinions on this? We want to make sure that we get the opinions of females and the opinions of males. And so we'll choose our strata based on that so that we have equal representation from both groups, especially if we think that's going to affect the overall responses of people. All right, now that you've picked out your seats, we're actually going to calculate how much these different fans enjoyed the show. If you turn the page, these are the ratings that all 50 people gave it. So for your sample number 1, for your simple random sample, go find the people in the seats that correspond to what you picked out on your method number 1 on your simple random sample. So where are those seats? You want to take those numbers, wherever they happen to be, add them up. And you're going to divide by what? By 10, because you sampled 10 seats. So starting with just your simple random sample, the people that were chosen in your simple random sample, method number 1, which people got chosen, grab your calculators, write them down, you want to add those up. Once you have all 10 of those numbers and you've divided by 10, so you've found the average, you need to calculate that average using your calculator. I'm bringing everybody a little red dot sticker. Once you have your average, you're going to go add it. We're going to make a dot plot over here on the one that says method number 1, simple random sample. So the 10 people that you selected for method number 1, your simple random sample, you're going to take those 10 values, you're going to add them up, divide by 10. Once you have your average, you're going to go put it on the poster that is written in red, method number 1, simple random sample. We're going to do this for all 3 of these methods. So after you've added your sticker to method number 1, You're going to come back. You're going to look at what you did on the front side, the seats that were selected with the second method. You're going to add those values up and calculate the average. So for sample number 2, where we did this by row, what are the 2 seats that you had in each row? And you're going to add those numbers up. Divide by 10 and find that average. Once again, dot stickers for the blue one. So stratifying by row, method number 2. If you don't know how to do it or where to put your sticker, please let me know. Yes, ma'am.
So it's like this, right?
Yeah, you should have 2 out of each row.
So
Yeah.
would it be 4 plus 6?
Not 4 plus 6, so you're going to take this seat right here on this side. So that'd be an 88.
Oh.
And then seat 6 in that same one. 1, 2, 3, 4, 5, 6. So 100.
Okay.
So you're going to choose those 2. And then you'll do the same for the next row and the next row and the next row. Yes. Yes. Okay, what was your number?
77.7.
77.7. So we're going to go 78, which would be like here. There you go. Once you've done that for method number 2, I also want you to do the exact same thing for method number 3, where we did it by column. So whatever seats you had picked out in these different columns, you should be adding those 10 numbers together. And finding the average. For the very last one, I've got green stickers coming around. Sorry, ma'am. Okay, cool. I just want to make sure that everyone knows what they're supposed to do. If we're not there yet, that's okay. Is this for you? Okay. I'm sorry, I'm like so right in the way here. Thank you. Yes, you may. Once you have your stickers up on the plot, you should probably start with the red one, but I want you to glance back here and get a sketch for each of these so that you have a copy of what this looks like in your notes for later. Notice that the scale in your book is just a little bit different. They're counting by ones in the book. I had to count by twos up here to be able to fit it all up. What do you notice as you look at those different dot plots? What stands out to you? Simple random sample is much more spread out than the other two. Stratified sampling reduces our variability. Stratified sampling reduces our variability. Simple random sampling has low bias. I'm actually going to take pictures of these and put them up on the board rather than try to recopy it. So hold on. I'm trying to get this one up here. See how much this messes up here. There we go. Mostly works. Right. This has low bias. It's pretty equally spread out. The true mean for this, because I did go ahead and calculate it, was 78.38. So 78.38 on ours would be right about here. Right about in the middle where we'd expect it to be, but it is much more spread out. Looking at the other one that we did. Let me get a picture of this one up for us. There we go, just get my picture up on the screen. And of course it's crooked. That's good enough for now, I guess. This one has low bias and low variability. What's the nice thing about low variability here? What are we trying to use these dots to predict? What are we trying to do on this? All the way back at the beginning, inside that box.
How many fans enjoyed the concert?
Yeah, we want to know, like, what's the overall enjoyment level? Most of the time, we don't have our true mean. We just have to get it from the sample. So low variability means that I've kind of narrowed the sides on this one. I have a much easier time of approximating where the center is because it's all kind of clustered around that center. And I apologize for how tipped that is. I'll fix that on the notes later. And then we've got our very last one over here. Let's see if I can manage to not get this one crooked. There we go. Come on. All right. This one up here was stratified by row. I ended up covering that up. This one was stratified by column. What do you think about stratified by column? Low variability, high variability? What are we thinking? Is this one more or less variable than the one up above it? We have low bias again. It looks to be overall low variability. I'm going to try to compare these two. Most of our data is in this space, right? How many points are not clustered right around the 80? 1, 2, 3, 4, 5. Looks like 6 points are not there. Here, if I look at the same kind of range right here, it looks like we've got 1, 2, 3, 4, 5 points. Yeah, this one also appears to have fairly low variability, so 5 points are away from that high point. Here we've got about 6. With 78.38 being our true mean. Which one of these three methods did the best job of approximating what the true mean was? Which one had the most points that were the closest to the true mean? Stratified method 2. We did have low variability here. But I would say that between these two, this one had lower variability, just because we had the majority of our points right in here. There is one other kind of sampling that we don't have time to do with this particular data set, and we're going to continue talking about sampling tomorrow, but there's something called cluster sampling. Cluster sampling, you know how we were using our random number generator and picking out like 1 seed out of each column or 2 seats out of each row? With cluster sampling, we'd go look at our rows and our columns, and we would pick out like 2 columns or just 1 row, and we would sample everybody in that space. Cluster sampling tends to be a quick, dirty, fast way it tends to have higher variability, but it would be a whole lot easier if I'm thinking about this actual concert. Like, all right, I need everybody in row 2. When you leave, you're going to exit this way, and you're going to take a little quick survey. It would be easier to collect that data, but we're going to see some of the same kinds of problems with cluster sampling that we see with convenience sampling. Not as bad, but it's going to have higher variability than our stratified sampling. All right. Snap a picture of this. We'll do the check your understanding tomorrow. But our big ideas: simple random sampling, label, randomized, select. We talked about that on Friday already. Stratified sampling. We split the population into groups. Those are called our strata. And we choose a simple random sample from each strata. Cluster sampling splits our population into groups based on location. This makes it easy to access our sample. We randomly select some of those groups, and we sample everybody in those selected groups. Tomorrow when you come in, I'll have this back up on the board again in case you don't get it all copied down right now. And then we'll start with the check your understanding, and then we'll move into more types of sampling. First homework assignment is due on Thursday of this week. And it is all about sampling stuff. Please let me know if you guys have any questions. I will also get your tests back to you tomorrow so that you can see your scores, and we'll talk about those.